Good morning. Welcome to today's GATE session. My name is Asha. I'm working as an assistant professor at S.A.E.C Engineering College. Today we are going to discuss about the topic inter-process communication in operating system. Moving on to the topic, introduction. Processes need to communicate with each other in many situations. So process is nothing but execution of any task or program is called as a process. So in order to execution of a task or a process, processes need to communicate with each other. So this is provided by a technique or a concept called inter-process communication, where multiple processes communicate with each other by sharing the data between the two or more separate or independent process. So this inter-process communication is facilitated by a operating system. It helps the processes to synchronize their activities, sharing the information between the processes, and it also avoids the conflicts while accessing the shared resources. Moving on to the types of process. So there are two types of process. The first one is the independent process, where the process that do not share any data or information with the other process. Here the execution of task or the program is done by an independent process. The second one is a cooperating process. So cooperating process is a process that shares the data or information with the other resources. So during the interaction between the other resources, there is a possibility for the conflicts to occur between the resources, which might result in a deadlock situation. In order to overcome this, operating system provides a facility called the inter-process communication. Moving on to the techniques used in inter-process communication. So this inter-process communication, it uses a techniques like sharing memory, sending messages, or using file concept in order to provide the interaction between the different resources. It ensures that processes can work together without interfering with each other, that they're reducing the deadlock situations. Fundamental models of inter-process communications. So there are two fundamental models of inter-process communication. So the first one is a shared memory concept, the other one is a message passing. So this is a diagram between the shared memory and the message processing model. So first let us see about the shared memory. In shared memory model, process A and process B, it shares the same memory. Process A writes the data to the memory, which is further used by the process B. Whereas in message passing method, process A, it writes a message to a kernel. So these messages stored in a form of linked list in a kernel, and the process B, it uses the messages which is stored in the kernel for processing the data or the information. So shared memory, inter-process communication through shared memory is a method where multiple processes are given access to the same region of memory. So as I said earlier, process A and process B, it can use the same memory for accessing the data or the information. The shared memory allows the processes to communicate with each other by reading and writing data directly to that memory area. It is one of the fastest inter-process communication because the processes communicate either by reading or writing the data to a shared block of the memory. So this is a block diagram of a shared memory. The process A, it writes the data to the memory, and process B, it reads the data from the same memory. Moving on to the message passing. In message passing system, processes communicate with one another by sending and receiving the messages over a communication channel. So this communication channel, we'll call it as a network. All the communication channel in the message passing concept are private. Message passing model allows multiple processes to read and write data to the message queue without being connected to each other. So the messages which are sent by the processes, different types of processes are stored in a message queue in the form of a linked list. So these message queues are stored in the kernel. Messages are stored on the queue until the receiver retrieves them. So the messages sent by the different processes will be stored in a message queue until the receiver reads those messages. So this is a block diagram of a message passing model. So see here in the process P1, it writes a message M1 which is stored in the form of a linked list in a message queue, and the process P2, it writes a message M21 to the message queue, and maybe process P3 or P4, it may read the messages from the message queue in order to process the data. Moving on to the approaches that are used in the inter-process communication. So there are different types of approaches used in inter-process communication. They are pipes, message queues, FIFO, shared memory, message passing, direct communication, and indirect communication. So let us discuss each and every topics one by one in detail. So first one is a pipe. So pipe is nothing but a data channel that is unidirectional. So this is a block diagram of a pipe. So here we could see that data is written to a pipe in one form, and the data is read from the pipe in the another form. Suppose if you want to create a bidirectional pipe, we have to use two pipes. So that is what given here. Two pipes can be used to create a two-way data channel between the process. It is a mechanism for a process to communicate and synchronize the data. Next one is message queue. So as I told earlier, the messages from the different processes are stored in a message queue in the form of a linked list. So this message queue will be stored in the kernel. These messages are identifier, message queue identifier, and these message queues are quite useful for inter-process communication, and they are used by almost all the operating systems. So this is a diagram showing how the message are stored in a message queue and how they are processed. So this is a sending process which sends a message in a form of a module which is stored in a message queue in the form of type and the messages. So what type of message it is and what messages are sent between the processes. And from the message queue, again in the form of a module, the messages are retrieved and it is sent to the receiving process. Next, moving on to a direct communication. So in direct communications, the messages are sent and received directly between the specific processes. Here both the sender and the receiver has to explicitly name the which processes is taking place in the communication. There are two types of communications that are involved in the direct communication. First one is symmetric communication, where both the sender and the receiver must know each other. For example, send P2 comma message and receive P1 comma message. So here P2 is the process. So here it is indicating that we are sending the message from the process P2 and the message is also attached along with this and receive P1 comma message. So here we are indicated that the message is received from a process P1 along with some kind of messages. In asymmetric communication, either the sender or the receiver alone can know the name of the resources from where the messages have been sent. Moving on to the indirect communication, here the processes communicate with each other through an intermediary called the message queue or the mailbox. So what the messages are sent and received from the mailboxes. So sender, they will send a message to the mailbox and the receiver, they will receive the message from the mailbox. Here multiple processes, they can share the same mailboxes. So example, send mailbox 1 comma hello. Here hello is a message which is sent to a mailbox 1 and receive mailbox 1 comma message. So here there might be any message which is received from the mailbox 1. So here the communication takes place between the receivers through the mailboxes. Next, moving on to the FIFO. So the full form for FIFO is first in and first out. So it is a method where data are transmitted the order it was sent. It is a named pipe. It is used for communication between the processes. It can be either a unidirectional one or a bidirectional one. This FIFO, it works by attaching a file name to the pipe. So these FIFOs are created using a called MK FIFO. So this is a block diagram showing how a FIFO works. So the red color oval, it indicates it is a server, and the green color oval, it indicates it is a client. So each server has one FIFO connected to it and each client has a FIFO connected to it. So this FIFO, it will send a request to the client and from the client, the requests are passed to the FIFO which is connected to the server. So this server, it will process the request and it sends the response to the FIFO connected to each client. This is how the FIFO works. Moving on to the gate questions. So the first question, which of the following is not a method of inter-process communication? And the options are pipes, message queues, semaphores and fork. And the option is fork because fork method, it creates a new process and it is not used for the inter-process communication. Second question, which of the following inter-process communication mechanisms provide unidirectional communication? And the options are named pipes, anonymous pipes, message queues and shared memory. And the option is anonymous pipes because anonymous pipes are unidirectional and it requires a parent-child relationship. Moving on to the third question, shared memory requires the use of a pipe to share memory addresses, a common kernel buffer, a memory mapped file, synchronization mechanisms like semaphores or mutexes, and the option is synchronization mechanisms like semaphores or mutexes because shared memory must be synchronized in order to prevent the race conditions or the deadlock situations to occur. Moving on to the fourth question, in message passing IPC, messages are exchanged through the registers, system calls, direct memory accesses and IO ports, and the option is system calls because here message passing involves system calls like send method or the receive method. Fifth question, which is a drawback of shared memory over message passing? And the options given are higher overhead, slower communication, difficult synchronization, less efficient. And the option is difficult synchronization because shared memory is fast but it requires the more careful synchronization methods. Sixth one, message queues are always synchronous, can be both synchronous and asynchronous. Use signals are slower than pipes. And the option is can be both synchronous and asynchronous. Moving on on to the 7th question. In a producer-consumer problem using a bounded buffer, which of the following is not needed? And the options are mutex, semaphore to count full slots, semaphore to count empty slots, condition variable to terminate the process, and the option is condition variable to terminate the processes. 8th one, what happens when a pipe's buffer is full and a process tries to write to it? The options are the write fails, the process is blocked, the buffer expands, the message is lost, and the option is the process is blocked because when the buffer is full we cannot write a data to it. As a result, the process will be blocked down. 9th one, two processes communicating via a pipe must be siblings in the same session, a parent and child relationship, and a parent and any descendant, and the option is parent and child because anonymous pipes, it requires a parent-child relationship between each other to complete the execution of the task. 10th question, which of the following is true about message passing and shared memory? The options are message passing is faster than shared memory, shared memory does not require synchronization, message passing is more suitable for distributed systems, shared memory is used only in distributed system, and the option is message passing is more suitable only for the distributed systems. 11th question, in Unix, which mechanism is used for signaling between the processes? And the options are pipes, message queues, signals, shared memory, and the option is signals. 12th question, which of the following is not true about the semaphores? They can be used to solve producer-consumer problem. They are used for synchronization purpose. They are only used in single-threaded applications. They can prevent race condition. And the answer is they are only used in single-threaded applications. 13th, a race condition can occur in inter-process communication when the options are one process waits for input, the multiple processes share data without synchronization, a signal is not delivered, there are too many processes, and the answer is multiple processes share data without any synchronization methods. 14th one, which of the following provides the lowest latency inter-process communication mechanism? And the options are message queues, sockets, shared memory, pipes, and the option is shared memory because shared memory allows direct access which leads to the lower latency output. Next question, which system call is used to create a shared memory segment in Unix? The options are SHM get, SHM mat, SHM dt, and SHM control, and the option is SHM get method because it allocates a shared memory segments. Thank you. See you in next gate session.